Good evening, ladies and gentlemen. We warmly welcome you to the final keynote session of MERCon 2025, the 11th edition of the Moratuwa Engineering Research Conference.
It is now my pleasure to invite to the stage Dr. Lihil Utpala Subasinghe, Program Co-Chair of MERCon 2025 and a Senior Lecturer in the Departments of Mechanical Engineering at the University of Moratuwa.
This evening, he will introduce our keynote speaker. Please join me in warmly welcoming Dr. Lihil Utpala Subasinghe.
A very good evening to you all, ladies and gentlemen. It is a great honor for me to introduce our distinguished keynote speaker today in this beautiful evening. And I believe you all know her already, Professor Lingjia Tang. She's a distinguished faculty member in the Department of Computer Science and Engineering at the University of Michigan. She's internationally recognized for her pioneering work in several research areas like artificial intelligence, computer systems, and conversational AI. And she holds a PhD in computer science from the University of Virginia, and she's holding her Bachelor of Science in computer science from Zhejiang University. And Professor Tang's research interests span several areas like computer architecture, computer technologies, runtime systems, as well as distributed systems. Her work focuses on building the next generation of computer systems that are faster, smarter, and more efficient, particularly for AI applications and conversational AI platforms. She has authored over 40 research papers in top-tier computer science conferences and has made substantial contributions to the field of computer science. Her research excellence has been acknowledged through several prestigious awards. I'll name a few: Google Research Award, Facebook Research Award, and NSF Career Award, as well as JPMC Faculty Research Award. Her impact on the academic community is further evidenced by over 8,600 citations, and with an H index of 38 and an I-10 index of 63. Since 2020 alone, her work has received over 5,200 citations. She's also listed in the Hall of Fame of leading computer architecture conferences such as International Symposium of Computer Architecture as well as International Symposium of Microarchitecture. So that is actually highlighting her strong influence in the field of computer architecture. Beyond academia, Professor Tang is a successful entrepreneur as well. She co-founded Clinique, a conversational AI company, where she led teams in designing and deploying large-scale AI systems such as the mobile virtual assistant for US Bank. This actually benefited or kind of contributed to over 6 million users. This effort earned several industry recognitions, including Frost & Sullivan Technology Leadership Award in 2019, Gartner Cool Vendor Award in 2021, as well as Crane's 40 Under 40 Award. She later co-founded Mica.ai, a platform that uses AI to help individuals to enhance their productivity and personal growth. In addition, she has contributed to real-world AI projects, such as a financial wellness application developed by the collaboration with Pocket Nest, further showcasing the practical impact of her research. Ladies and gentlemen, with a warm round of applause, please welcome Professor Lingjia Tang.
Thank you. Hi. Oh, okay, it works. Great. Thank you for the wonderful introduction. That was awesome. Yeah. Oh, let me actually. I think it's locked, right? Fantastic. I thought AI can do everything now, right? Anyway, so it's a pleasure to be here. It's my first time in Sri Lanka. What a beautiful country here, and wonderful people. So thank you for having me here. All right. So today I'm going to talk about AI and models, right? Like everyone else. So it's suffice to say that we're in the model explosion abundance era, right? So nowadays, ever since 2023, ChatGPT, nowadays, I think looking at models is like going to a buffet, right? Pick what you like, right? Here is a recent model sort of landscape, cost to run those models, log scale, and some kind of metric for intelligence. So whatever you like, right? Whatever budget, whatever intelligence, okay? Tons of models, right? Another wonderful thing, we were talking about how expensive to run those models, right? And it's amazing how much progress we could make in, let's say, I don't know, 6 months for reducing the computation overhead of inference. Okay, this is a log scale, by the way. 32 to, if you look at this one, this is actually the most intelligent model we have nowadays. Okay, so we're actually making from 32 to 0.0 something. Okay, orders of magnitude within 6 months of inference cost reduction. That's what the power of when you throw billions of dollars by big corporations and throw intelligent people into this problem, right? Why? Because we have better hardware from NVIDIA, right? We have intelligent people working on model architectures like MOE, like DeepSeek. We also have a lot of software system innovation. We have algorithm innovation, of course, quantization, and then we have algorithm innovation. And we also have system software innovation in terms of how we actually organize the KV cache. So lots of domains, a lot of people throw tons of energy and reduce the inference cost, right? It's an amazing achievement. Third thing, right, is if you're looking at sort of progress on the intelligence of those models, the blue line being the open source model and the black line being the proprietary models, we're actually not too far behind. Okay, so we're catching up from an open source perspective to the big corporations of the OpenAIs and the Googles, right? A little bit behind, but you know, that's not bad. So everything is awesome. Wonderful, fantastic, the future is bright, right? Wonderful buffet, anything you want, cheaper and faster and smarter and open. And is it a nagging voice in your head to ask, is that what it is, right? How many applications you use really powered by AI, right? All right. Have you guys heard about this big user revolt recently? This is an article from Wired on August 11th, so a week ago. So this big ChatGPT, how many people actually heard about this actually? Okay, so ChatGPT, OpenAI released ChatGPT 5. They made a big deal out of it. This is going to be the most amazing. It's supposed to replace all of us, right? It's supposed to be smarter than us, PhD level, right? They claim PhD level intelligence. Replace all of us, okay? And what people think is not all users think they like it. They actually hated it. Actually, on Reddit, it was a big, no, we don't like this. Bring ChatGPT 4 back. Actually, someone said, sure, 5 is fine if you hate nuance and feeling things. Okay? So apparently, a lot of people think it's a wrenching downgrade. That's what the Wired actually thinks. All right? So surprisingly dumb mistakes. What does that tell you, right? Tons of models. We can't get one thing right, which is we don't even know how to evaluate them. All right, we don't really, especially we don't know how to evaluate them based on human preferences, right? OpenAI doesn't know. We don't know. And we're all engineers here in the room, right? And if you can't evaluate a thing, how do you really know you're improving them? You don't, right? But this is really just a tip of the iceberg, really evaluation, right? As a matter of fact, in engineering domain, we all know once you don't know how to evaluate, there are many things you can't do, right? You don't really know how to actually verify things. You can guarantee a lot of actually metrics. You can make progress. But if you really think about the problem going from, if you think about from model to application or true product, there's a lot of complexity, and evaluation is just a piece of it, right? And that begs the question that really actually is one of the questions I think is we are now seeing a lot of models, tons of models. We're now seeing a lot of products. We're now seeing a lot of applications that are really powered by those models, right? We haven't really solved all the problems downstream from a good model to an application. And let me just actually talk a little bit about that. Some of the people here are AI experts. Some people may be more adjacent than close to this, so bear with me. So from model to applications, what is the current journey it looks like, right? So let's say I have a model. So I have an open source model, right? Since I could go to the buffet and pick one. So now I have to really make something out of it, right? What do I do? So this is the long journey nowadays that you have to go through. So let's say you have a pre-trained model. So those are the foundational models people already trained for you, right? We're not talking about the OpenAI sort of pipeline. We're talking about someone like just want to use an open source model, cheap model, but really capable, and want to actually build an application out of it. So we first have to actually look at all the models and make a selection. Which one do I want to use for my specific use case, right? How do I actually pick one? There are tons of them out there. After I actually pick one and I have to do some post-training, well, I don't have to, but it would be smart for you to do some post-training, right? Such as fine-tuning. So pre-trained model comes with parameters already set up for me. Fine-tuning is basically saying that I'm going to just freeze some of the models, most of the models. I'm going to actually tweak some of the parameters in the model, right? So much less training time. But for the specific task or domain you're focusing on, you're actually going to train the part of the parameters, or you do some kind of a reinforcement learning to get some human feedback on specific domain you care about, all the actually technique. There's a lot of work on this one, which is post-training. And the idea is you have a foundational model for the almighty model, right? But you want to actually post-training it for a specific task that you want to actually handle, right? On top of that, you could do some of this. This is a magic. This is a mess. This is tons of work you need to do and need a lot of actually knowledge. And then on top of that, you're not done yet, right? On top of that, you have to do system-level aggregation, augmentation, which actually includes, for example, RAG, which is retrieval augmented generation. We're going to talk a little bit about that, right? So basically, you're going to augment this model with more domain knowledge, documents, so it could do retrieval for you. Lots of work on, lots of work on prompt engineering. You guys probably heard about this from the earlier talk. To integration orchestration, this is a lot about agentic AI, so you really have to get the model to use the tools, right? So how does it actually do web search for you? How does it actually, like, for example, book flight tickets for you if you want agentic AI capabilities, orchestrations? You have tons of models talking to each other, agentic style, and all of that. And this is not exhaustive list, right? This is actually a lot of things people do on top of that. And then we're not done yet. Yeah, then we're going to try to deploy it, which also is a mess too, right? Because once you deploy it, let's just say you could deploy and manage actually inference cost, all that stuff, latency, typical engineering stuff, and then you have to monitor the quality, how is it actually aligned with humans, actual feedback. Now you have to actually improvement, go back to here, and try to figure something out. Okay, that's the journey. And lots of companies are doing this, billions of dollars spent, and the rest of the world are trying to figure out this. Like, how do I take advantage of it? All right, so long journey. And And this, I think, is the reason that we say IT leaders don't trust AI agents, but really they don't trust the AIs. And the number right now is 2% of the organization have fully deployed actually AI. 2%. If I ask anyone here that actually use AI to really solve their problems, the problems, I don't know. I talk to ChatGPT, and maybe I use Cursor to vibe code sometimes, right? But really, you don't see mass adoption of products that really are powered by AI yet because of the challenges, okay? All right, so in today's talk, I'm going to focus on, I can't really cover all of that, and there's tons of interesting work by our group and also a lot of people on this entire pipeline. I'm going to talk a little bit, sorry. All right, clickers. About model evaluation, so how do I evaluate models, and a little bit about augment models for better results. Okay. Don't know if you can see this example. This is example, a real chatbot talking to human. This is actually a chatbot deployed by Chevy, so it's a car dealership. And I don't know if you can see it really, because the color is a little bit. Basically, this chatbot is trying to sell a car with $1. Okay, it's offering a person with $1. So it's difficult to evaluate. Somebody deployed this. Somebody may not really have the job anymore. Okay, but how do I actually evaluate a model to actually have behavior as expected? It's very challenging because standard benchmarks don't really work well. So standard benchmarks we typically use for input, output, ground truth, whatever that we use for testing and evaluation. It doesn't really work well for generative tasks, right? So if I ask ChatGPT to write me a novel, how do I know this is the best novel, right? How do I compare that? I don't really have benchmarks for it. I can't deal with open-ended tasks. I can't capture the preferences. Some people might like, you know, novels or summary more thrilling. I don't know, but you know, people have different preferences. So someone came up with a solution. I don't know. So it's called battle. If I say, hey, tell me why you think you're the smartest AI, model A says, short answer, I don't actually think or hold belief, blah, blah, blah. I think model B is trying to convincing me that actually I am the smartest AI. That's fascinating. Let me define what smart is. How many people think left is better? How many people think right is better? Pick one? Not really? Oh, I guess you guys think both are bad? Both are bad? Oh, it's a tie. You're going to have to vote. I think it's kind of hard for me to pick. I think I slightly like the right better, right? I mean, it's trying to tell me about define AI, and this is a little bit robotic, but I bet if I actually do a poll here that you truly vote, it's going to be a very split answer. Some people think A, some people think B, some people agree, blah, you know. And if I actually ask thousands of people, tens of thousands of people, I'm going to aggregate all the data. You could ask any kind of questions, then I start to actually get a sense, right? So this is a key idea behind this company called Chatbot Arena. It used to be an open source project from Berkeley. Okay? The idea is basically saying, hey, I'm just going to actually a user pick. I'm going to cross out this ID, this sort of comparison. So let's say I have 4 models. I'm going to do pair-wise comparison. Okay? Because apparently a human cannot deal with 3 options. All right? Yeah, it's like if you have kids, my toddlers, like you have to give option A, option B. Okay? Let them pick. 3 is going to throw a wrench to the entire thing, and the brain explodes, right? And so, okay, option A, option B. Tell me which one you like better. Different questions, different battle. Think about this. This is kind of tennis match, right? Soccer match. You want to see who is the best at chess. Who is the best chess player, right? That's the ELO score, right? So the idea is basically, ELO score is basically saying you have tons of matches, and I'm going to compare, aggregate those data, which is pairwise comparison data, A versus B. It's a head-to-head pairwise. And I'm going to throw all the data into a ranking algorithm, and it's going to give me a rank. Okay? This is historically we will actually rank, like I said, chess players. Okay? Which they use a different algorithm, but similar idea. All right? So they use this ranking algorithm to aggregate pairwise results. What do you guys think about the solution? Thumbs up? Thumbs down? Yeah? Well, either way, this company is raising actually $100 million with a $600 million valuation. They just got 100 mil for this simple idea. All right? Because we're out of, maybe we're out of ideas, I don't know. But they solved a problem. I guess solved, to be continued about the solved part. But they proposed a solution that everybody is using now. The world is using this. Everyone is using it. Companies using it, individuals using it. We use this to pick models. And the market thinks they deserve 600 million valuation for this idea, just to evaluate models. But is that it, right? Obviously, it's a but to actually, I'm not here to talk about Berkeley work. I'm here to talk about the work I believe in. So there's a big but there, right? So we actually found, so we did some work. We're looking at this. We're actually a big fan of Chatbot Arena, so we did some work on this. Oopsie, 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 oopsie. Okay. We found that the result actually, the ranking actually differ very differently depending on the ranking algorithm. So we all actually provided our cross-selling data here, and depending on the algorithm you pick, ELO was the one Chatbot Arena was using. They switched to Bradley Terry, and there's other actually options out there. You actually get very different rankings. What does that mean? We're actually back to ground zero. We thought we solved this problem, right? We could rank them now, but then we realized that a bit of a random. I could just throw a different ranking algorithm in there, and now someone else is actually the winner, right? Okay. So we actually did a little bit more research, and we actually published a paper, and this is actually the press release of the paper that we published called Why AI Leaderboards Are Inaccurate and How to Fix Them. And you could check out this paper. It actually came out just last month in ACL, which is one of the best natural language understanding conferences. And it's called Ranking Unraveled. And so at a very high level, we basically established criteria for how we select a ranking algorithm. So how do I know a good ranking algorithm is good? Right? It's just an in-depth study of this. And we evaluate 4 commonly used ranking algorithms and create, at the very end, we create a guideline for how to actually use ranking algorithm. We give the recipe as at what situation should you choose to use what algorithm that you should actually trust the result. How do you know what's good? There's a lot of things that go into there: stability, consistency, predictability. I don't have time to go into all the data. There's tons of data in the paper because it's a bit of an evaluation paper. But I'll show you one example. We actually look at those 3 actually ranking algorithms, and this is when we actually change the hyperparameter of those ranking algorithms. Some of the ranking algorithms came with hyperparameters too, as well too. So if you actually change the ranking hyperparameter, you could see the big ranking jump actually here. Okay, it just means that this algorithm is really not stable. So if you just set the hyperparameter wrong, your ranking of the actually models will actually change drastically. Right? So you really need expertise to set the hyperparameters which make this algorithm very difficult to use. Okay, all right. And there's recommended best practice. It turns out that the one ChatGPT is, Chatbot Arena is using Bradley Terry is actually really not good for the particular set of data set they're actually sampling. They actually have very uneven data set because they actually, new models get played more, right? But okay, served offer recently, but actually has less of data, so you actually should actually use other algorithm. But there are situations Bradley Terry actually work really well. If you actually just do smaller data sets, then it works really well, okay? So either way, the conclusions I don't think matters that much. But the high level I want to say is there's a lot of work in evaluation that you need to do, right? You can't just trust the ranking algorithm or leaderboard to give you results. If you really want to look at your use case, you really need to dive a little bit deeper, okay? And on top of that, we did a little bit follow-up work on still evaluation, actually, is, so recently, LM as a judge becomes really popular as judging LMs, okay? Because guess what? Chatbot Arena lets people to sort of compare models to collect cross-sourcing data, but in reality, it's very difficult to collect crowdsourcing data. Imagine a company that basically say, I want to pick models, here are the 10, pick one for me. How do I hire 1,000 people to rank those models for me? Maybe I could do that if I have money, but if I don't, what do I do, right? So people just actually come up with something like, well, why don't we just throw this problem to the AI? So AI is going to judge the model for me, right? So hey, we don't know what we're doing, but we trust AI does the right thing. So query goes to models, and models, oh my goodness, I'm really not good actually using clickers. Goes to models, model generate response. AI is going to be like, let me see. You know, obviously, ChatGPT always like ChatGPT's answer. Never rank anything higher than itself, but you know, but there's no bias in this problem at all. In this solution at all. It's completely fair, right? Okay, so obviously the problem is it's not really calibrated, right? And you would say this is such a silly idea. Do we really do that? Majority of the paper published nowadays in natural language understanding actually use that to show that their models are better. Right? The entire academic community are using that to judge their work are doing better now. Okay, that's how commonly used this actually strategy is, because we just don't have energy to actually hire enough people to actually rank models. So the follow-up work, which I also won't get into super detail, but the key idea is we're going to actually use small amount of human data to quickly calibrate the model, and we'll use max entropy calculation, which is very low overhead to calibrate using the human data. We're roughly using 10% of the data and get very high results that's very correlated with humans, okay? And outperform a lot of actually prior work. I don't know if I have the results table here, but I have the archive paper listed here, so you can actually read it if you are curious. This is submitted to ACL as well, so the key idea is, hey, cross-sourcing is not good, it's too expensive. LLM as a judge, you can't completely trust the models, you have to figure some way to calibrate the model to actually, so it aligns with the human judgment. Right? Oh, I actually have some results here, so great. So this is how, sorry. This is how bad some of the use cases we have, the correlation of previous evaluator. So the numbers should actually go from 0 to 1. Negative means it's not correlated at all. It's actually negatively correlated. So this is how bad all the actually prior work is in terms of calibration result, and we actually outperform them but significantly, and actually a lot cheaper as well too. Okay. All right. So I'm not going to switch gears a little bit from evaluation to the other problem. Like I said, evaluation is just a piece of the sort of tip of the iceberg, right? And also, I don't claim that we solved the evaluation. I think tons of work needs to be done about evaluation, and it really is the first step to rigorously actually pushing AI community forward. Okay. And honestly, I can't really even state how much time we actually spend on arguing about metrics. I work with Jason and Dr. Ranga. We're just sometimes looking at the table and just like, those metrics don't agree, and they have all the pros and cons, so we don't know which one to trust. Oh well, you know, so hey, so evaluation. All right, anyway. So I'm gonna switch gears to talk about augmentation for models, okay? This is actually a wide ocean of work that's in augmentation of how to use models, right? How to manage models, how to orchestrate models, how to augment models, how to customize models. But just a bit of a prior work, retrieval augmented generation is probably the one that's getting the most attention, the hype, right? And the key idea, just for people who are not super familiar with AI about RAG, is essentially it's a way to actually augment a bunch of documents to the AI models, right? So just think of it as a student taking the exam, and the student actually get a notebook as sort of a cheat book that they could go to find some answers, right? That's the augmentation you're providing for the LLM, the language model, to actually come up with generate answers. So the idea is really also simple too. It's basically say I have a knowledge base, typically documents. I'm going to actually use an embedding model to make it as document embeddings. I'm going to chunk it and I'm gonna basically just cutting into different chunks, putting in the vector database. So when user comes to query, the query is gonna go there, and it's just gonna use very simple similarity matrix. It's gonna find the data chunks that's very similar to the query, and this is gonna give to a LLM to generate some answers. Okay. Most of the chatbots you're seeing nowadays in the market, like if you talk to any AI and then you ask them questions about documents or whatever, it's using this. Okay, that's what we use nowadays. But it's linear in nature, which is actually one of the key limitation of this. You really just chunking documents, right? Just make it as a vector representation, and it actually ignores the relationship between data chunks. So we run into a lot of situations that knowledge, human knowledge, actually are not a linear document, right? You remember anything in your brain is probably not organized in a linear way, right? You have work, and you have like hobbies, and kids, and finance, and other things you manage, whatever. That's not organized in a linear way. I certainly hope not so right now. But, you know, and all the knowledge in the world is not organized in a linear way as well, right? Very standard way to do this is to actually do sort of knowledge graph. This, I don't know if you can see clear, but it's basically showing you a sort of the health related, actually medicine related knowledge. So it's basically disease symptoms, drugs, treatments, and so on and so forth, and that's how it's organized. So now the question is, how do I actually, you know, retrieve information in this? Right? Which is the most natural way of organizing documents. Right? If you throw a rag to this problem, it's not going to solve anything. It doesn't know. It's going to ignore all the edges. It's going to linearly chunk everything, and you know, it's not going to give you the best answer. So we really have to figure out a way to retrieve based on knowledge graph. Okay, so we actually work with students and actually submit this paper. Savini and Janica actually from the University of Moratuwa here, so they graduated here and came to Michigan and work with us. Actually, Dr. Logie actually introduced us to those students, so fantastic students. So we worked together and actually submitted this paper called Graph Runner. So just really quickly, actually, how we solve this problem. Let's say you have a question about what illness situated in urine that could be treated by mitomycin. I don't know what that is, whatever. All right, and as you have a knowledge of the health, well, clearly I'm relying on AI to answer that question. I don't know what it is, but to a knowledge graph, right, that tells you this is kind of some kind of compound, I guess can treat some problems, and there's urine, and what illness could happen, so there's some disease that's linked to urine. So what we're going to do is we're going to give this question to a traversal planning module. So basically, we ask LM to do graph traversal. So what we're going to tell this model is this question, the graph structure, so what kind of nodes, disease type or compound type, what kind of edges those nodes are connected with. And we're also going to tell LM, here are the few things you could do. Okay, you could find a node of type whatever. You could find a common node between two node types. Okay, you could find the specific edge type from this node. So if you sort of think about it as traversal capabilities you could do on this graph, and we give this to LM, and we just say, come up with a plan. All right. So LM is going to say that step one is I need to find a node with autonomy, that's urine, and we need to find a disease, we need to find a compound type that's mitomycin, right? Next step is I'm going to find a common node between those two that's connected with certain edge type. So this is the traversal plan that's generated by LM purely by reasoning and understanding the traversal capability it can do, and the graph structure. The next step we actually have is we have a verification module. This is because LM sometimes hallucinates, so we need to verify that it's actually doing the right thing. The steps are reasonable and actually respects the graph structure. Once the plan is verified, we execute it. So basically, here, so we find urine, we find this compound, we we know that the LMs is saying that we need to actually find the disease that actually is in this autonomy, and then need to find the edge compound treating disease and find a common node here. And based on those 2 steps, we actually identify the disease and retrieve back, right? So this is not doing linear, so the retrieval like RAG, and this is basically doing a graph traversal. And sorry. Bring your own clicker next time. That's the lesson here. All right. All right, so Graph Runner and text-based RAG, graph-based RAG, and Graph Caught, some of the work by Microsoft, and this is showing actually we're doing a lot better than some of the prior work in terms of actually across different domains. And again, not claiming we're solving the problem, just to say that this is one example of, there's a lot of things beyond training the model and pre-training that we need to do how to really use model to be smart, right? So last slide really is 2 things. If you walk away from this, actually, you can ignore anything I just said when it comes to the papers and the results and the approaches, because that's all details, right? But high level, I just want you to walk away with 2 things. One is human alignment is very, very important when you actually do AI research, like the human preferences, how humans think, so on. And the second thing is there's a lot of work that could be done in the entire pipeline of customizing and augmenting the model beyond just pre-training the model, which is kind of like similar to the previous keynote for Jason, where training is not important. I don't think I go that far to say training is not important, but I would say that there's a lot of important work beyond training that we could do. All right? And you don't have to be working for Google to work on those problems. Those are the problems you could solve, right here with the resources you have. Okay. All right. With that, questions? I don't do. Is there like a system for question, or you could just? I guess you could just raise your hand and. 100 million for 600 million valuation. I get 300K for the open source project. Not quite 100 million. I think if I have to answer that question, that's actually, it might be turning into a rant. I think there's part of the research nowadays, and maybe it used to be, but nowadays it's more of, I call it the eyeball research, right? But it used to be, okay, we go to conferences, we're going to publish our conferences, we're going to pick the best of the conferences or the journals and whatever. But this may be an AI thing, this may be a computer science thing, but I think nowadays it's very much like open source, stars, eyeball, social media, right? It's becoming a lot of like that, right? So you really have to publicize your work. And the reason they got this actually funding is because there's millions of people that are using it, right? They don't have the best perfect solution, but they managed to actually get lots of people to use it. So for people who are here, thinking about publicize your work, I highly recommend yours. Encourage you to say, A, make it very useful, practical, easy to use for general people, and B, really go out to actually publicize your work. Think of the creative way to publicize your work, because nowadays we're moving to that direction that, if people have short attention span and they want something quick and they want to see something from the social media. And I think Berkeley is great at that, right? And there's nothing against them. They're really good at publicize their work. So yes, it's kind of hard, but honestly, I feel like internet sort of level the playfield to some degree, right? You could say it used to be, okay, sure, you should have to be in the top universities. But I think nowadays with the internet, LangChain is coming from somewhere I don't even still remember where it's coming from, right? But it's not the top university. It's just some actually coder. I think it's a developer at some random company that decided to code this and decided to make it actually open source, and it really took off, right? So I do think it actually leveled the. That's an encouragement to myself to go for that 100 million. And everyone here. All right. Any more questions? Oh. Yeah. Right. Right. Okay. Actually, it's a great question. I think there's more actually research to be done there. In the study that we showed, is 10% of the human data than the ground truth is what we use to actually show. The question is about the using human data to calibrate LM as a judge. That piece of work. How much data do I need for? Do I need different data for different models? Right. To answer the first question, for that result, we use 10% of the data that actually as a baseline ground truth. But do I need different data for different model? The answer, if you look at that in the improvements, quite different across different models. So I think the answer is yes, but we don't really have a way to know how much data is truly to get us to the actually good results. And I think to throw a nuance to that is actually human preferences are very different, right? And it's not just the model, it's also the task as well too. So if you have very noisy data where humans have very different preferences, how do you know like you're really calibrating to true human preferences? Like what is true human preference anyway, right? How do you actually let people to provide that data? So there's a lot of work to be done on that piece of work. So a great question. All right. Dr. Rega. Oh, hold on. Oh, okay. Hi. Yeah. Right. That's a great question. Like, how do I actually traverse a huge graph, right? Like, how do I actually, if I actually do the graph, um, we don't really have. Uh, I don't think we're doing anything very intelligent or customized for actually the graph traversal. We just do the graph traversal. Uh, but I think there's smart things that could be done for the latency. So far, it's not too bad. We actually measured the latency in the paper that I could actually we could share, but I don't think it's actually really bad. It's actually better than the prior work as well too. Um, but you're right. Like if you have very complicated traversal capability, like questions that require very complicated traversal and many steps, that will actually really increase the latency that we actually probably need to work on those actually latency as well too. A good question. So Dr. Ranga, do you have a okay. All right.
The traversal planning module, is it domain specific? Can you talk more about it?
It's designed now to be domain specific, right? Because it's so basically the LM, which is actually I think the animation is a little bit small, but we gave the LM the graph. Let's say it's a healthcare or whatever, right? We just say, hey, the healthcare has this types of nodes, this type of edges. So the planning module is not domain specific, but it needs the specific information from the graph.
Yes.
And then the traversal actions, it's really just like find common nodes, find nodes that have 2 hops away with whatever connections.
Right.
So it doesn't really have any domain-specific knowledge in there.
Yes.
And actually, the results we show is actually across different domains that we actually perform pretty well.
Right.
So I think it's designed with generality in mind, but I wonder if there's actually really complicated graph where those traversal actions may not really suffice. Well, so far, we haven't seen much of it, but
Right.
it's possible. Yeah.
Yeah. Thank you.
Yeah. Good question. All right. If no questions, thank you guys. It's great to have me here. It's great to be here. It's my great pleasure to be here. All right. And then get up the stage.
Thank you, Professor Lingjia Tang, for your insightful keynote speech. Your thought-provoking exploration of how AI can become more trustworthy and human-aligned was fascinating. We greatly appreciate your valuable presence and are honored to have such an esteemed scholar and leader with us here today.
As a gesture of our gratitude, we kindly request Professor Lingjia Tang to come back on stage as we present a token of our appreciation.
To present the token of appreciation, I cordially invite Professor Vasandapriyan, Chair of IEEE Sri Lanka section.
Accompanied by Professor Jagat Manatunga, the Dean of the Faculty of Engineering, University of Moratuwa.
Thank you. This symbolizes our heartfelt thanks for your time, effort, and the invaluable knowledge you have shared with us today. Thank you, Madam. With our keynote session concluded, we'll take a brief break. We'll resume shortly with the award presentations. You won't want to miss it.
Ladies and gentlemen, distinguished researchers, and esteemed guests, a very good evening to you all.
It is with great pride and anticipation that we finally welcome you to the awards ceremony at the banquet of the Moratuwa Engineering Research Conference 2025. In the ever-evolving landscape of academia, where curiosity is boundless, innovation flourishes, and knowledge drives progress, this conference stands as a premier forum for intellectual exchange and technological advancement.
MERCon 2025 marks the 11th edition of this prestigious international multidisciplinary engineering conference, organized by the Engineering Research Unit in collaboration with the IEEE student branch of the University of Moratuwa.
This gathering is the culmination of months of dedication, rigorous review of research, and collaborative effort. MERCon embodies the very spirit of scholarly pursuit, the unyielding quest for understanding, the drive to address complex challenges, and the commitment to shaping a better future through engineering excellence.
Ladies and gentlemen, after 2 days filled with innovation, collaboration, and insightful discussions, we now turn our attention to the pinnacle of MERCon 2025, the award ceremony.
As we gather here under the brilliance of ideas, let the excitement in the room rise as we prepare to honor the trailblazers who have left an indelible mark in their respective fields.
We now commence this momentous occasion with the lighting of the traditional oil lamp, a cherished symbol of new beginnings and shared enlightenment. For this, I now warmly invite Professor S. Wasantapriyan, Chair of the IEEE Sri Lanka Section,
Professor Jason Moss, Professor of Computer Science, University of Michigan, Professor Lingjia Tang, Department of Computer Science and Engineering, University of Michigan,
Professor Jagat Manatunga, Dean, Faculty of Engineering, University of Moratuwa, Senior Professor Ruan Gopura, Dean, Faculty of Graduate Studies, University of Moratuwa,
Professor Dilika Dias, Conference Chair, MERCon 2025, Professor Buddhika Jayasekara, Director Research, University of Moratuwa,
Dr. Sulochana Suryarachi, Director, Engineering Research Unit, University of Moratuwa, Mr. Nayan Dharmaraj from Dialogue Asiata Labs,
Sanjula Gatsara, Chairman, IEEE Student Branch of the University of Moratuwa,
one author representing the authors of MERCon 2025,
Thank you.
Before we unveil the winners, let us reflect on the inspiring words shared throughout the day.
We've had speeches that ignited our passion, discussions that expanded our horizons, and a keynote address that challenged us to reach new heights.
At this time, it is my privilege to invite Professor Dilika Dias, Conference Chair of MERCon 2025 and Professor in the Department of Electronic and Telecommunication Engineering at the University of Moratuwa, to deliver the welcome address. Professor Dias has displayed a pivotal role in guiding and shaping this conference, bringing together her academic expertise and unwavering commitment to its success.
Please join me in warmly welcoming Professor Dilika Dias to the stage.
Thank you very much. Good evening, ladies and gentlemen. Professor Jagat Marathunga, Dean Faculty of Engineering, Professor Ruan Gopura, Dean Faculty of Graduate Studies, our keynote speakers, Professors Jason Maas and Ling Jia Tang, officials of the IEEE Sri Lanka section, dear staff members, heads of departments, and all the session and track chairs of MERCon 2025, nominees for the Best Paper Awards, and our sponsors, Dialogue, Vidul Lanka and Commercial Bank. It is my privilege and pleasure to welcome you all this evening to the awards ceremony and the banquet at the conclusion of MERCon 2025. Organized by the Engineering Research Unit of the University of Moratuwa, this year marks the 11th edition of MERCon, which has become the flagship conference of our university. MERCon evolved from the Engineering Research Unit's annual symposium called the ERU Symposium on Research for Industry. I remember the very first ERU Symposium held at the university in 1995. I think of all everybody in the audience here, only Professor Lucas would have been there for that event. I too presented a paper, so I remember that very well. And it was the first time ever that the university had organized such a conference. So there was a lot of excitement in the air, although it was a very simple affair compared to today. It had only one morning session and one afternoon session, as I remember. So many from industry were also present. A few years later, the ERU started publishing peer-reviewed abstracts as a booklet with an ISSN number. And then, so that continued, the ERU Symposium improved, gathered momentum, and after nearly 20 years, building on that experience, the Faculty of Engineering decided to graduate this event to an international conference with full papers, which are, of course, peer-reviewed and now published as published as proceedings. So it is now an international conference that is technically co-sponsored by the IEEE with its proceedings present in the IEEE Explo since 2015. So this year MERCon features over 400 papers submitted, out of which 170 were selected, and I think 150 or so were presented in 19 or so tracks. And we had 152 registered participants. We had 3 brilliant keynote addresses delivered to packed audiences, and 5 workshops on cutting-edge topics. So MERCon has come a long way due to the dedication of generations of teams taking the leadership to steer this to greater and greater heights every year. So as we enjoy this evening, I encourage you all to reflect on the inspiring ideas shared and the connections formed during the conference, and let these be the foundation for further collaboration as we advance the frontiers of engineering knowledge together. So on behalf of the organizing committee, let me welcome you all again and thank you for your presence and thank you for being part of the MERCon journey, and may the evening be enjoyable and the conversations fruitful. Thank you.
Thank you very much, Professor Dilika Dias, for that warm and inspiring welcome address. Your words set the perfect tone for the exciting lineup ahead for this evening's award ceremony.
Before we proceed, we'd like to take a moment to thank our wonderful sponsors, without whom MERCon 2025 would not have been possible.
Today, we will be presenting tokens of gratitude to the representatives who were able to join us in person, while also acknowledging every sponsor who has supported this journey.
To present the token of appreciation to our gold sponsor, Dialogue Axiata PLC, we now invite on stage Senior Professor Ruwan Gopura, Dean of Graduate Studies,
accompanied by Dr. J.R. Gamage, Publicity Chair, MERCon 2025, and Senior Lecturer of Department of Mechanical Engineering.
To accept the tokens of appreciation, we now invite on stage Mr. Nayan Dharmaraj from Dialogue Axiata PLC.
Next, we invite Professor Vasantapriyan, Chair of IEEE Sri Lanka Section, our technical co-sponsor of MERCon 2025.
Next, we invite Ms. Umaya Balagalla, IEEE Sri Lanka Section, EMPS, our technical co-sponsor of MERCon 2025.
Next, we invite Dr. Samiru Gayan, Chair of IEEE Sri Lanka Section, Signal Processing Society, our technical co-sponsor of MERCon 2025.
Thank you for joining us. We also extend our thanks to our silver sponsor, Vidul Lanka PLC,
and our bronze sponsor, Commercial Bank.
Thank you for your continued support in pushing the frontiers of engineering research.
We also thank our merchandising partner and technical co-sponsor, the IEEE Geoscience and Remote Sensing Student Branch Chapter of the University of Moratuwa.
as well as our technical co-sponsors, IEEE Sri Lanka Section Computer Society, IEEE Sri Lanka Section Industrial Application Society, IEEE Industrial Electronics Society,
IEEE Sri Lanka Section Geoscience and Remote Sensing Society, IEEE Sri Lanka Section Circuits and Systems Society,
IEEE Sri Lanka Section Robotics and Automation Society, and IEEE Sri Lanka Section Power Electronics Society.
Now, let's take a moment to celebrate the spirit of creativity and culture. For that, we present our next item, a captivating dance performance that blends artistry and elegance. Please sit back, relax, and enjoy this beautiful showcase.
I hope you were as captivated by that beautiful dance performance just as much as I was.
Without further ado, let the spotlight shine on the first act of our awards ceremony.
Firstly, we'd like to take this opportunity to present a gift to our esteemed keynote speakers for sharing their invaluable time with us and enriching this year's event with their outstanding research profile.
May I now invite Professor Buddhika Jayasekara, Director Research of the University of Moratuwa, accompanied by Dr. Sulochana Surya-Arachi, Engineering Research Unit, University of Moratuwa, to join us on stage to present these gifts of our appreciation.
To begin, may I invite Professor Lingjia Tang to the stage to accept this token of our gratitude.
Now, may I invite Professor Jason Maas to the stage to accept this token of our gratitude. Thank you for joining us.
Now, I would like to invite Professor Sanat Jayawardena to the stage to brief us on selection criteria for the Best Paper Award on behalf of the Awards Committee of MERCon 2025.
Professor Sanat Jayawardena is a senior professor in the Department of Textile and Apparel Engineering. Please join me in warmly welcoming Professor Sanat Jayawardena.
I would like to brief about the selection criteria for MERCon 2025. Best papers are selected, then for nomination of the best papers are selected based on the review score received. And these are, in order to qualify a track for the best paper award, there should be at least 3 papers. If the number of papers less than 10 in a track, then 3 papers are nominated. And if the 10 or above paper count is in a track, 5 papers are selected. Then highest review score papers will be nominated for the best paper and subjected to all positive reviews. That means borderline or higher. Then presentation of the nominated papers are evaluated by the session chair and panelists on the day of the conference. Final total score is given by this formula. 0.6 of the paper review score and 0.4 of a score received for the presentation are considered in evaluation, calculating the final score. Next slide, please. Award committee comprised of Samiru Gayan, Professor Buddhika Jayasekara, Dr. Gayan Nandsiri, and myself and Dr. Indrajit Nisanka. I would like to thank them all for their individual contribution in selecting the best paper. Thank you very much.
Thank you, sir. From the intricate dance of mechanical engineering systems to the electrifying performance of power systems and the symphony of big data, machine learning, and cloud computing, the stage is set for a dramatic unveiling of brilliance.
We will now begin the presenting the nominees and winners for the Best Paper Awards for each track, honoring the most outstanding contribution of MERCon 2025.
Starting with the nominees for the Best Paper Award in the Biomedical Engineering and Instrumentation track are classification of same limb motor imagery, EAG using temporal attention-based hierarchical transformer, a unified deep learning approach for the segmentation of breast masses and calcifications, a clinically interpretable rule-based algorithm for detection of premature ventricular contractions. And the Best Paper Award in the Biomedical Engineering and Instrumentation track goes to classification of same limb motor imagery, EEG using temporal attention-based hierarchical transformer, authored by Minidu Lienege, Pasan Gunasekara, Ramit Laksara, Ruwan Ranavira, Janaka Vijaykulasuriya, Nalin Harish Chandra, Taraka Dasanayaka.
To present this award, I would like to invite the Dean of University of Moratuwa on stage. The nominees for the Best Paper Award in the Chemical and Process Engineering track are investigation of drying kinetics of the heat pump drying and post-drying quality parameters of mango by using glide arc plasma discharged pretreatment. Kinetic analysis of dairy sludge pyrolysis using the Coates-Redfern method. Machine learning driven discovery of photocatalysts for solar hydrogen production. Overcoming band gap prediction challenges with transfer learning.
To present this award, please join me in welcoming Senior Professor Ruwan Gopura, Dean, Faculty of Graduate Studies, University of Moratuwa. Dr. Lihil Subasinghe, Senior Lecturer of the Department of Mechanical Engineering in the University of Moratuwa. design and experimental validation of a non-invasive plasma density sensor for plasma-enhanced process reactors, authored by Indula Monesinghe, Shashini Kularatne, Iresha Jeevanthi, Subramaniam Thayaparan.
The nominees for the Best Paper Award.
Thank you for joining us.
The nominees for the Best Paper Award in the Engineering, Mathematics and Statistics track: Engagement in Professional Tasks with Generative AI versus Cognitive Skills, a case of IT industry in Sri Lanka. Optimization of transport networks with special reference to fluctuating demand for fisheries.
To present this award, please join me in welcoming Dr. Gayani Nandasiri, accompanied by Dr. Sandarekha Vikramanayaka.
And the Best Paper Awards for the Engineering, Mathematics and Statistics track goes to Engagement in Professional Tasks with Generative AI versus Cognitive Skills, a case of IT industry in Sri Lanka, authored by Sandani Ranatunga, Ravindi Jayasundara and Bimali Jayasinghe. Dear madams, please remain on stage to present the next award as well.
The nominees for the Best Paper Award in Geotechnical Engineering track: Effect of coir husk fiber on rice husk ash and cement-based peat stabilization, exploring the suitability of fly ash and rice husk ash in one-part geopolymer, a case study for sustainable low-carbon construction. Stability analysis of expansive soil slopes stabilized with geogrids. And the Best Paper Award goes to Effect of coir husk fiber on rice husk ash and cement-based peat stabilization, authored by Yasanti Jayapatna and Sampath Hevage. Dear madams, thank you for joining us on stage to present these awards.
Up next, as the Best Paper nominees in the Hydraulics and Environmental Engineering track, we have Assessing Compound Hydrometeorological Extremes and Their Transformative Impacts on Stream Flow in a Changing Climate, Machine Learning and IoT-based Water Distribution System for Reservoirs in Sri Lanka, Assessing the Performance of HEC HMS Model versus Machine Learning Algorithms in Predicting River Discharge, Experimental Investigation and CFD Modeling for Enhancing Pipeline Performance for High Concentration Fly Ash Slurry, and Weighted Multimodal Ensemble Approach for Robust Monsoon River Flow Projections.
To present this award, please join me in welcoming Professor Udayani Navagamua, Head of Department Civil Engineering, accompanied by Professor Manisha Gunasekara, Head of Department of Chemical Engineering.
And the Best Paper Award for the stream Hydraulics and Environmental Engineering goes to assessing compound hydrometeorological extremes and their transformative impacts on stream flow in a changing climate, authored by Dasunmi and Kumar Siri and Luminda Gunawardana. Dear Madam and Sir, please remain on stage to present the next award.
The nominees for the Best Paper Award in Image Processing and Computer Vision track: Distillation Boosted Spiking Neural Network for Gesture Recognition, Enhancing Video Generation Based on Text-to-Image Diffusion Models using a Multimodal Approach, Few-Shot Early Defect Detection in Industrial Manufacturing using Explainable Siamese Networks, Unveiling Misalignment Fault Severities, a novel SCD-CNN framework for rotating machinery, a comparative analysis of similarity-based retrieval for SVG logos. And the Best Paper Award goes to Distillation Boosted Spiking Neural Network for Gesture Recognition, authored by Madhava K. Aponso, Tusantan Jathasan, Ishara Udita Vallaheva, Chaturanga Hettiarachi. Dear Sir, dear Madam, thank you for joining us on stage to present these awards.
Up next, as the nominees for the Best Paper Awards in the Material Science and Engineering track, we have Electrospun PVA nanofibers reinforced with cotton-derived cellulose nanocrystals, a sustainable route to high-performance nanocomposites. A theoretical model for thrombin generation kinetics in the initial phase of the extrinsic pathway of human blood coagulation. Developments of an optical particle counter. Tailoring zinc oxide nanostructure for enhanced capacitive UV response. And finally, eco-friendly approach to cellulose recovery, extraction and characterization from Salvinia molesta.
To present this award, please join me in welcoming Professor Niles Pereira, accompanied by Dr. Tushara Subasinghe.
And now, the best paper in the Material Science and Engineering track goes to Developments of an Optical Particle Counter, authored by Akimson Arasaratnam, S. Amarasinghe, Dinesh Atyagalli, Sampath C. Veragoda, and Bandhu Samarasekara. Dear sirs, please remain on stage to present the next award as well.
Next, as the nominees for the Best Paper Award for Mechanical Engineering Systems track, Enhancing Combustion Performance in KNSU Solid Rocket Propellant, Experimental Study of Coconut Shell Charcoal as a Sustainable Additive. Comparative study of theoretical and numerical analysis to evaluate the aerodynamic performance of a helical vertical axis wind turbine. Development of marine-grade ABS-based hull of an underwater drone. Monolithic, 3D printed, 3-chamber pneumatic soft gripper for delicate rock-up manipulation. Design of glass fiber reinforced composite blades for a 1 kilowatt small-scale wind turbine. Evaluating the quality of traditionally peeled versus machine-peeled cinnamon. design and development of a regenerative suspension system for electric vehicles. And the best paper award goes to comparative study of theoretical and numerical analysis to evaluate the aerodynamic performance of a helical vertical axis wind turbine. Authored by Sandalika Udani, Dayan Abevira, Samita Hera, Indradit D. Nisanka, Nalaka Samaravira. Thank you, Sis, for joining us on stage.
Up next, as the nominees for the Best Paper Award in the Power Systems, Electrical Machines and High Voltage Engineering track, we have Seamless Transition between Operating Modes in a Microgrid Cluster, Optimal Integration of Distributed Generators in Medium Voltage Radial Distribution Systems using Enhanced Particle Swarm Optimization Algorithm, and last but not least, modeling and parameter tuning of the governance system at Lakvijaya Power Station for turbine load control mode of operation for enhanced stability.
To present this award, please join me in welcoming Dr. Tharaka Samarasinghe, accompanied by Dr. Kasun De Silva.
And the Best Paper Award goes to Seamless Transition between Operating Modes in a Microgrid Cluster, authored by W.E.P. Sampath Edirvira, Lidula Nilakshi Vidanagama Arachige. Yes, sirs. Please remain on stage to present the next award.
Next, we have the nominees for the Best Paper Award in Robotics and Intelligent Systems track. Brachiation robot inspired by Gibbon Dynamics, insights for control across irregular bar spacing and heights. Context-aware trilingual conversational service robot at restaurant. Development of a dexterous manipulator for underwater cleaning. And the Best Paper Award goes to Brachiation robot inspired by Gibbon Dynamics, insights for control across irregular bar spacing and heights. Authored by Heishan Madhusanka Pereva, Ranjit Amarasinghe, Dumit Jaitilaka, Eranga Da Silva. Thank you, Sis, for joining us on stage to present these awards.
Up next, we have the Software Engineering and Cloud Computing track. The nominees for the Best Paper Awards are Optimizing Energy Efficiency in Cloud Environments through Hybrid Workload Prediction using CNN and LSTM. Intent Classification for Automated Software Deployment Plan Generation, a transformer-based approach. Data Sovereignty in Multi-Regional Identity Systems.
And to present this award, please join me in welcoming Professor Dilika Dias, accompanied by Dr. Jayani Sudhasinghe.
And the Best Paper in the Software Engineering and Cloud Computing track goes to Data Sovereignty in Multi-Regional Identity Systems, authored by Madhuranga Sirivardhana and Indika Pereira. Dear madams, please remain on stage to present our next award.
The nominees for the Best Paper Award, Structural Engineering and Building Materials track. Relative tsunami vulnerability of structural materials across tsunami events. detection of multiple structural damage through model analysis and experimental and FE approach, study on methods of testing tensile strength of concrete, analysis of bending stiffness, reduction in thin woven composites under large curvatures, design-aware optimization of 2D skeletal structures using conditional generative adversarial networks. And the best paper award goes to detection of multiple structural damage through model analysis and experimental and FE approach, authored by Charit Madhuwantaratnayaka, Hasid Damruan Hidalana Gamage, Sujiva Levan Gamage. Thank you, madams, for joining us on stage to present these awards.
And now, we've reached the track of supply chain, logistics, and mobility engineering. The nominees for the Best Paper Award in this stream: Redesigning Supply Chains for Industry 5.0 in Developing Economies, a Research Agenda. Barriers Influencing Application of Supply Chain Research in Practice, a practitioner's viewpoint through a fuzzy Delphi AHP approach. Optimizing Delivery Logistics, a comparative study of clustering algorithms for zoning restaurant orders. Advancing UAV Implementation for Medical Supply Distribution, a systematic review of current practices and future directions. Delphi-driven insights into artificial intelligence implementation in sustainable supply chains, navigating barriers and strategic enablers.
To present this award, please join me in welcoming Professor Udeni Navagamur, Head of Department of Civil Engineering, accompanied by Professor Manisha Gunasekara, Head of Department of Chemical Engineering.
And the Best Paper Award in Supply Chain, Logistics, and Mobility Engineering goes to Barriers Influencing Application of Supply Chain Research in Practice, authored by Ruanga Nayanarashi Dayavansha, Jaini Sudhusingha, and Nimantha T. Thalagala. Yes, sir, and madam, please remain on stage to present the next award as well.
Up next, we have the nominees for the Best Paper Award for Sustainable Energy and Environment track. Co-pyrolysis of textile dyeing sludge with waste cooking oil, a dual waste management approach for producing efficient dye absorbent. Modeling elephant migration and deforestation hotspots in Sri Lanka's dry forest using hybrid CNN LSTM architectures and cellular automation. Comparative effects of ground calcium carbonate and marble dust on morphological and yield responses of corn in acidic soils. Do all the vehicles pollute more? Insights from emissions testing data in Sri Lanka. Strategic decision framework for sustainable retrofitting, decarbonizing small and medium-sized hotels in tropical monsoon climates. And the Best Paper Award goes to Co-pyrolysis of textile dyeing sludge with waste cooking oil, a dual waste management approach of producing efficient dye absorbent, authored by Hashini Kandanagedona, Timeshi Herat, Chanako Deanga, Shakira Pathiran, Jagat Manatunga. Yes, sir and madam, thank you for joining us on stage to present these awards.
For the Technology Management track, as the nominees for the Best Paper Award, we have Can machine peeled cinnamon fulfill the requirements of Ceylon cinnamon markets? And Service Process Improvement through VSM of Lean Six Sigma, a case study.
To present this award, please join me in welcoming Dr. Jayamali De Silva, accompanied by Professor Sanat Jayawardena.
The best paper award goes to Can Machine Learning Peeled Cinnamon Fulfill the Requirements of Ceylon Cinnamon Market? Authored by Hasit Wijetunga Gunasekara, J.R. Gamage, and Adus Amarasinghe. Yes, sir. And madam, please remain on stage to present the next award.
Next, the nominees for the Best Paper Award, Textile and Apparel Track. We have Sheath-Free E-Yarns through yarn covering for enhanced knittability. Investigation on nanostructural color for fabric printing using silicon nanoparticles. Fabrication of microcapsules with N-octadecane, co-and melamine formaldehyde shell for enhanced thermoregulation in textiles. And the Best Paper Award goes to Sheath-Free E-Yarns through yarn covering for enhanced knittability. Authored by Ashmika S. Gamage, Nipun S. Sudaraka, Sharika S. Gunavardhana, Muhammad Aslam, Charmika Madhurangi, TSS Jayavardhana. Thank you, sir and madam, for joining us on stage.
And as the Best Paper Award, in our last, final track, Transportation Engineering, we have as the nominees, Leveraging Vehicular Test Databases to Develop a National Emissions Prediction Model, a case study for Sri Lanka. NOx emission estimation and prediction for newly registered motor cars using type approval data and machine learning techniques. Enhancing subgrade strength of rural roads constructed on soft soils using varied grades of coir fiber. Performance evaluation of asphaltamine modified warm mix asphalts.
To present this award, please join me in welcoming Dr. Bimali Jayasinghe, accompanied by Dr. Wakisha Manamperi.
The Best Paper Award goes to Leveraging Vehicular Test Databases to Develop a National Emissions Prediction Model, authored by Shastri Sankar Jayawardena, Saman Bandara, Varuna Adhikariwattige, and Tusita Sugatapala.
Thank you, madams, for joining us on stage to present this award.
Now, let's give a big round of applause to all our brilliant nominees and winners of the Best Paper Award.
Ladies and gentlemen, before we conclude this esteemed gathering, please join me in welcoming Dr. Sulochana Suriyarachi, the Organizing Committee Chair of MERCon2025, to deliver the word of thanks.
Good evening. It's a great pleasure to address you at this occasion. Dear sirs, Dean of the Faculty of Engineering, Professor Manatunga, Dean of the Graduate Studies, Professor Gopura, Director of Research, Professor Buddhika, and all our conference chair, Professor Dili Kadayas, senior, very senior, Professor Lucas, and all my academics in the University of Moratuwa, my team,
the MERCon team, and most of all, the authors and my team, the students. I'm really confused where to start because it's a big effort and big team. So let me start with the very first effort that we had with IEEE Sri Lanka section and its chapters. We started applying for the financial co-sponsorship this year. And we of course got it granted, but unfortunately the process was going to be long and we had to do it on time, so we had to go back to technical co-sponsorship. So throughout that process, I really thank Professor Priyan and all the team in all the chapters who responded very quickly. By the way, by doing that process, our quality of our team, the evaluation process and everything was improved and got into a higher standard. And in that process, even the civil engineering and materials engineering, all those people had to take IEEE membership on the way. I think IEEE would be very happy about that. I'm not sure whether they will renew it, by the way. And then next was this preparation for the conference. We had a big team and they had a lot of work as well. And we got the highest ever number of paper submissions this year, 457. And out of that, 104, guess which track? Data science and artificial intelligence. We could have done a conference on its own with that number of submissions, and Dr. Sandareka had the hardest time assigning reviewers and getting review on time, and by the way, she did it well. And all of our track chairs had a hard time because the university itself was on a tight schedule. They had a lot of marking, IESL accreditation, and various things on the line still, with little bumps. We could complete the review process, and I should apologize for some authors. Their notification came very late. We couldn't help because of this. Everything was priority, so we could not help at some times, right? Anyway, thank you for bearing all that delays, and also thank you for the hard time. And the reviewers, they also had a very tight schedule, but still they did a wonderful job. They did very insightful reviews, and that is why you would understand this, the screening process brought the best papers out of the best. And then after the notifications, it was again another set of lot of activities, and we had to find money, and people had things to arrange. And I would like to thank everybody, the electrical department for sure, Ms. Cherashmila. You brought the first spark and bringing Vidulanka into the sponsorship category when we had none. And Professor Manatunga helped us reach commercial bank, and Professor Dilika, she did a wonderful job joining dialogue in this case. And Nayan, thank you for joining today, and all the last minute approval. You had a hard time. Thank you for everything. And then the GRSS Society, IEEE, sorry, Dr. Sureka had to leave for an urgent work. She did a lot of effort. These nice, pleasant green color T-shirts are from GRSS. The society became the merchandising partner. And the Computer Society, the EMBS, and the RAS, IAS, AES. So all whole list, I'm sorry if I missed any, all the IEEE society chapters, chapter societies, thank you very much for the technical co-sponsorship. And then we have the audio-video team, the dancing team, and at the university during the daytime conferences, the institutional affairs, the supplies division, the finance division, they all helped. And the bursar, registrar, the vice chancellor, they helped. Throughout the process, we had urgent purchasing. Due to these various delays, we had to do certain things in the last minute, and they all supported. I should thank them. And the IEEE, the University of Moratuwa student branch, they did their best. They did a wonderful job managing all the ground level work. And I should thank all of them in helping me bring to this level, MERCon. Because after a long time, we came out to a hotel to have a banquet. So throughout, I think it's in 2019 or so, we had one last. And Professor Buddhika may have some history about it when we had the last banquet. Yeah, it's 2019, as I remember. Right, so thank you for everyone for bringing us back to a bit of a glamorous setup in a hotel. So I would like to hand over, I mean, this is my last year as the director, ERU. Of course, I'm getting relaxed time after this. And the next ERU director will have a hard time. We are pushing them to get IEEE financial co-sponsorship, and I hope we can start now itself about that. With that, my hope, my vision, or the wish for the next director to bring MERCon to be a regular IEEE conference next year. With that hope, I would like to conclude my talk. Thank you, everyone. And for the authors, thank you very much. You trusted MERCon. I hope you will continue to trust MERCon.
Ladies and gentlemen, with a heartfelt word of thanks from Dr. Sulochana Suryarachi, we now arrive at the grand finale of MERCon 2025. I echo those words of gratitude and extend my deepest thanks to each and every single one of you for your active participation, insightful contributions, and unwavering enthusiasm throughout this remarkable conference.
Over these inspiring days, we have witnessed the true spirit of engineering excellence. In every keynote, every presentation, every spirited discussion. This has been more than a conference. It has been a celebration of curiosity, innovation, and collaboration.
As we bring the curtains down on MERCon 2025, let us carry forward the lessons learned, the friendships forged, and the sparks of inspiration ignited here. May these moments continue to fuel your passion and guide your journey in the world of research and innovation.
To our esteemed speakers, committed organizers, generous sponsors, and engaged participants, thank you for making MERCon 2025 truly unforgettable.
And now, before we officially close, we invite all of you to join us in the front for a group photograph, a moment to capture the people who made this event so special.
Afterward, we warmly welcome you to enjoy the conference dinner. Now open as we relax, connect, and celebrate the success we have created together.
Thank you once again. Safe travels, continued success, and we truly hope to see you next year with even more groundbreaking research, inspiring ideas, and shared achievements.
I'm Charlie Shakira.
And I am Hasit Netikumara, signing off. Thank you, and good night.